Hello everyone, thank you for taking a few minutes out of your day to watch this presentation. I want to share with you a software package called Digitally Fabbed. And this is a software package that will allow you to take your 3D CAD models and turn them into physical products in the real world. But before we get into that, I want to talk to you guys a little bit about myself. I've always really liked to make stuff. In my adult life, I'm constantly designing and building things in my shop, anything from arcade machines to furniture to trade show booths. And in my youth, I was always taking apart something in my house, much to the dismay of my parents. And some of my current projects are things like this. This is a digitally designed and digitally cut wooden desk that raises and lowers, and this was done by designing it in CAD, bringing it into a machine, and then cutting all the parts and milling it in my shop. I've also participated and helped on projects like this. This is a digitally fabricated house that is all designed in CAD, cut on a CNC machine, and assembled using only a couple ladders and some mallets. So it's essentially making a home into a big IKEA kit. This is another recent project of mine where I was tasked with designing an arcade machine, and this combined not only digital wood fabrication, but also graphic design, electronics, and sound to bring this all together to make a pretty neat looking and certainly very loud arcade machine. And I do this using all digital fabrication tools, whether it's printing stickers or painting graphics. A lot of the tools that I use are small to medium-sized CNC machines, laser cutters, and 3D printers. But what do I like more than making things? I'm really passionate and I really enjoy giving people the tools to make their own stuff. So let's talk about the process of getting a digital design into the physical world. No matter what tool you're using or what it is you're designing, you've got to design it in CAD. And typically this means building a 3D model of the thing that you want to make. Next, in the case of 3D printers, laser cutters, CNC machines, torches, water jets, pretty much any machine that's driven by a robot, you need to bring it into CAM. And CAM stands for Computer-Aided Manufacturing. In most CAM softwares, you're importing a CAD model from another piece of software, you're bringing it into CAM, and you're setting it up to be exported to the actual physical machine. So after you prepare your model in CAM, you export it to the machine, and you can go off and make your part. Now, this process has been around for a long time because CNC machines have been around for a long time, and 3D printers, although newer, work on that same technology. So you may have actually seen this in real life and not realized it yet. But the typical process is design your thing in CAD, bring it into CAM, and then put it up for sale on the web or wherever else. And that works fine, but you've got to jump from CAD to CAM and then to the web. And these are three completely different platforms. Now here's the problem. Let's say you design something like this cabinet and somebody wants to change the size of it. Well, the problem with this process is that you need to start all over again. You've got to go back to CAD, redesign your object, put it back into CAM, and then put it up on the web or for sale again. So with all the products that we buy that have variations like cabinets and houses, shoes and bikes, you can imagine all the different scenarios where you would need to resize a product so that you can make it again or make a variation of it. And this process is called Parametric Design, where you can design something in CAD and have it resizable either infinitely or to user set constraints. And there are software packages that have solved this. Two examples are Autodesk Inventor. They make a very expensive and very complicated mechanical design piece of software that you would use for car parts or other mechanical things. And then a more proprietary one called Cabinet Vision. They've actually solved this problem for the cabinet industry. The problem with these softwares, though, is they're meant for machines that are well over $100,000, and the individual software packages at their lowest go for about $5,000 each, and they're incredibly complicated to use. They make sense in the context of large manufacturing where you can invest multiple employees into learning the software and designing your whole product line to work in it so that you can scale your manufacturing. Now, this is not where we want to compete with our software yet. That'll be some years down the road. But what we want to do is serve small and medium businesses so that we can make nimble and light software. And instead of doing big, industrial, complicated machines, we want to serve all of these small to medium-sized machines. These are machines used by hobbyists and prosumers, schools, and small to medium-sized shops. And we want to serve tools like CNC machines, laser cutters, and 3D printers. So let's talk about some places that you'd find these machines. You'll find 3D printers and CNC machines at schools and colleges and makerspaces all throughout the country. These are typically used by hobbyists and in education, obviously, and we think that this is a big up-and-coming market. The maker movement is huge and growing every day and every year. But also, these machines are used in real businesses and wood shops and metal shops throughout the country. These are small shops doing anything from one-off product to small production runs. These are, real businesses, typically about $15 million or less is the category that these businesses fall into. And these businesses are currently underserved by software. The software that a lot of the schools and not only these small and medium businesses use is called Vectric. They've got about 60,000 plus users in their product. They sell a range of products, anything from $150 up to about $3,000. I believe that their typical sale is somewhere between the $1,200 and $3,000 range, depending on the features that you need in their software. And their software doesn't do the full stack of things that these businesses need. All of these businesses need to be able to design in CAD, go to CAM, and then sell their products either in a configurable way directly to their customer or on the web. And Vectric only does CAM. So they only allow product to be imported from other CAD softwares, be set up for toolpaths in their software, exported to a machine, but they don't help you do anything parametric or anything with the web. Their current market share, this is a survey done by CNC Cookbook every year, so this excludes sort of free and hobby software and high-end industrial software, so this is right in the middle. Vectric's got about a 41% market share, and they only really have that because all of the other options just aren't good at all. Now, the thing that they don't do at all is this ability to do parametric design. So you can design your cabinet or whatever it is, another piece of software, bring it into Vectric, and then it's sort of stranded there. So if somebody wants to, again, resize or change that product, you've got to go all the way back through this process over again. Another entrant into this market is Autodesk Fusion 360. This is a newer entrant by Autodesk, which is a big and reputable company. And Fusion 360 is essentially a watered-down version of Autodesk Inventor. So they took a big, complicated mechanical design piece of software, took out a bunch of the features, and have made it available for users on these medium and smaller machines. And on paper, their package offers CAD and CAM, no ability to put anything on the web. And they've got about 60% market share in the free hobbyist market. And this is because they're offering their product for free. And while it's a good product, it does not address all of the concerns that people have. It's a very awkward to use piece of CAD software, and the CAM software is frankly very over complex, and it's difficult for hobbyists to use. However, it is the best choice in a sea of pretty bad choices. So that's why currently they have the largest market share in the free sector. So what it is that we want to build is this full stack. So we want to build CAD software, we want to build CAM, and we want to build the ability for people to take these designs, put them on the web, and make them parametric so that they customer can reconfigure a product, and the maker can immediately have machine code that they can go off and machine to make this process of iterating on your designs a lot easier. So building a piece of CAD software is really, really hard and very, very expensive, and that's why only a few companies have done it. Takes a long time, costs a lot of money, and we want our CAD software not only to be a good CAD software, but we also want it to be able to do this. We want to be able to people to make parametric designs so that they can resize them at will. So instead of designing from scratch our own CAD software, we want to build on top of SketchUp. SketchUp is a free for hobbyists and very inexpensive piece of CAD software that's used by 30 million people. It's got a very open API, so you can build applications on top of it. In fact, we already have a product that we've designed on top of SketchUp that's successful. And it actually is in wide use by our audience. Almost everybody in the school and makerspace and medium-sized shops use SketchUp for either initial design or they're designing their products and then exporting them for import into other CAD and CAM software packages. So our audience is already very familiar and very accepting of SketchUp. For the CAM portion of our solution, we would need to build something from scratch. The existing solutions that are out there are either too simple or too complex. We want something right in the middle. And our CAM software would target a wide variety of machines like CNC machines, 3D printers, torches, and lasers. But all of these machines have a common communication protocol in place, so that if we build essentially a G-code exporter for SketchUp, with a little bit of tweaking, it will work on a wide variety of different machines like this. And this will let people, again, get from CAM out to just about any machine in any size, in any configuration, as long as it talks with the the open standard called G-code. Now for the web portion, this is something that we would need to design as well. And what we want to do is use an existing SketchUp web renderer that will allow you to take a SketchUp model and render it on the web, so that somebody could go to a website, see a 3D model of the product, change options that the designer has made available to them, and then add it to their cart and purchase it. And that maker who posted that design there would get ready to make machine code. They wouldn't have to go back to their CAD software or their CAM software. They would have machine code that is ready to go. And we think this would be great for websites like Houzz and Etsy and people just selling direct on their own websites. And there's a decent chunk of this technology already built because SketchUp actually has a web-based 3D renderer. So we wouldn't need to build that part. We would just need to build the product configuration part. So let's talk a little bit about our market value. So there are 100,000 plus users right now using working in medium-sized shops and buying medium-priced CNC software packages. We actually think this market is a lot better, but we can verify that there has been this amount of pieces of software purchased for this reason. The woodworking industry, which we think is a place that SketchUp is widely used and where our product will be adopted first, is a $5.4 billion industry in the United States alone. And these are wood shops making $15 million or less, and again, doing one-off product or small production runs. And they all could benefit from software like this. We also think that there's about 135,000 users in schools and colleges and makerspaces throughout the country. We want to do subscription model pricing. Vectric, would be our closest competitor, sells only on Windows and sells only as a one-time purchase with a discounted upgrade. And we think that people are used to and expect subscription model pricing now, and we think we could convert a lot of customers over by offering a low-price monthly subscription rather than a really expensive one-time purchase on a single platform. So why do I want to do this? I have a real passion for making. I have a real passion for helping people make. I travel all over the country and I teach people how to do this stuff, and I see all of the problems and the headaches they run into. This is not an easy process. And you see 3D printing and all of these sort of magical things online. It's always made to look really easy. And the reality of it is that these machines, they're robots. Digital fabrication machines have incredible potential, and they're limited only by software. And I want to unlock the power of these machines and these designers and all of these people around that want to do anything from design a crazy house or a new robot, or just want to make their shops more efficient and run smoother by making easy to use software. So what do we need to do this? We need a couple of developers to start with. These are people that have expertise in building on top of SketchUp. We already have a couple people identified, and we also, shortly after we get a working prototype, we'd like to get some people in marketing to really get the word out. So at this stage, we are looking for seed funding to get this started. And that is Digitally Fabbed. Thank you very much for watching this presentation. If you have any questions, please reach out. I'd be happy to talk to you.